Welcome all. Welcome to class 44. We'll start with one example to check whether this is stationary or not. The assumption here is assume that it has infinite history. Even if this is not written infinite history, we always accept with infinite history. AR are the long-term models. We'll do MA today. We'll see they are the short-term memory models. Okay. Question is XT, left hand side, in the right hand side, you have two terms plus one random shock. You can say white noise. So then you need to check for stationarity. This is AR2 process, and you have to write the polynomial. This is the AR2 process. You write the characteristics polynomial. For this, you have to solve this. You will get 2i here divided by 2, that is minus 1 plus or minus I. Okay, these are the roots of the polynomial. Now you check whether the roots are, the absolute values of the roots are greater than 1 or not. Now these are complex numbers, so you can write this way. One is minus 1 plus I, complex number. This is minus 1 minus I. If you take absolute value, when you take absolute value of complex numbers, you have to take this way. You write minus 1 or 1, it doesn't matter. Even I have to write minus 1 here. So in both the cases, you will get square root of 2. So these are greater than 1. That means these are outside the unit circle. Okay. If they are outside the unit circle, then what will happen? This is your 1 and this one. This is the unit circle. Okay. And you need to check whether roots are within this or not. This is 1. This is 1. If you write this point here, minus 1 plus 1, that is minus 1 minus 1, that will come this side. This is minus 1 minus 1. And here, this one minus 1 plus 1, the first one. Minus 1 plus 1. Okay. So that will come here. If you join this is greater than 1. That is what? This is greater than 1. This is greater than 1 in magnitude. Okay. Modulus means what? The distance. The distance from origin in complex numbers. The real numbers are here on x-axis. You can write 1, 2, 3 and imaginary numbers here. Okay. So this way you get a stationary time series AR2 here. Okay, let me go to another example. Consider this equation. Minus 1 upon 6 concepts apart, you have to know the computation also. If you are able to calculate, then you will be able to do the problems. Okay, so you will get a question mostly numerically you have to answer in the exam, though concepts are separate. So for that also you need to learn separately. Okay, that means this is the way you need to find row naught, row 1, row 2. These are the autocorrelations. The question is find the autocorrelations. We have Yule-Walker equations, but we'll go to those later. One way is this one you need to learn. Let me replace it by xt. So suppose I want to find gamma 1. Then I'll write gamma 2 here. If I write gamma 1, that is covariance of xt minus 1. Remember, you have to follow a particular way. Even if you write xt plus 1, that will be correct. but that will create a lot of problem once again. This is the standard way. All the time you have to do this way. You need to write the values, okay? Whatever xt is, 5 upon 6 xt minus 1 minus 1 upon 6 xt minus 2 plus et, then xt minus 1. If I write gamma 2, then also you have to write this way. Let me write gamma 2 here. Covariance xt minus 2. Then you will get covariance. The same formula I will write xt minus 1 minus 1 upon 6 xt minus 2 plus et, then xt minus 2. Okay, so what you are doing is we are just substituting the values from the left here in both the cases. Let me write gamma naught as well. Covariance xt here, that is covariance so the first one where you see xt, there you need to substitute the value whatever is given in the right hand side. So now this is AR2 process, remember AR2, and you have to find the autocorrelations and autocovariances for AR processes this way. If MA processes are given, I will go to those later anyway. We have different ways of finding. Okay, so remember this is the standard way. Then we have to write here separately covariance xt minus 1 xt minus 1, you can write this way, covariance AC plus BC plus DC, that way separately. Okay, so plus covariance minus 1 divided by 6 xt minus 2 xt minus 1, then the last one plus covariance ET xt minus 1. Now 5 by 6 you can take out. When you find covariance xt minus 1 xt minus 1, they are the same. Okay, same point. If you have the same point, then it will be gamma naught, you remember. Then the second one will be minus 1 upon 6. Here xt minus 2 xt minus 1. See the lag here, the difference between the time point. There is one time lag, t minus 2 t minus 1. So you have to write gamma 1. Okay, it doesn't matter. Covariance ET xt minus 1. ET xt minus 1, when you write, this will be 0 because we are trying to find the correlation of random shock today. Suppose the random shock today you want to find, the error today you want to find, basing on the last figure. That means, suppose I am giving you classes, whatever time I will give you, okay, the amount of time I will teach today, how that is dependence on yesterday. If there is a dependence, that is already captured within the deterministic part, in the stochastic part. Today, the random shock will be according to today's conditions. It should not have any impact on the last value of the process itself. So the random shock today, here, the random shock today, whatever time I plan, there might be deviations due to some reason, okay, which will be due to today's conditions. It has no link with whatever happened, okay, the process. It has no link with the process. So this will be 0 all the time. This is 0. This one will not contribute. And the left hand side will write here. This is the first equation. This is the first equation. What you need to do now is to divide everyone with gamma 0. If you divide by gamma 0, this will become rho 0. Suppose I will do this way. So my first equation is actually, in the left hand side I have rho 1. Rho 1 is equal to 5 divided by 6, and here minus 1 divided by 6 rho 1. I hope this is correct. Okay, let me write this is equation 1. This is the first one, and then let me go to the next one. Similar to this, we'll find gamma 2 here. Okay, now if you check this one with this one, this will give you gamma 1 because there is a lag of 1. If you check with gamma, xt minus 2, xt minus 2, it will give you gamma naught. And there is no link between et and xt minus 2. It's independent of the past of the process. This is the random shock today. That's why in our model, there is a stochastic part. So the stochastic part of today, the random shock, white noise, whatever you say, that is no link with the past value of the processes anyway. So this will be 0. So our second equation will be this. Let me write here only. While writing, you can see this equation. Okay, this equation here, xt minus 1, we can write t minus 2 here. You just replace this one. So now this and this, okay, there is lag 1. So I can write left hand side is 2 here. So rho 2 is equal to, the first one is t minus 1, t minus 2, that is lag 1. Okay, so 5 upon 6 gamma 1, and you have to divide. So you will get rho 1 minus, from the second one, they are the same, gamma naught. Okay, minus 1 upon 6 gamma naught. When you divide by gamma naught, it will be 1. This is the second equation. However, when you find gamma naught, this one, then what will happen? If you check special to gamma naught here, xt minus 1, that is there. So you will get gamma 1 from here, 5 upon 6 gamma 1. And the second one, if you see 1 upon 6 xt minus 2, then xt. This will be 2 here, minus 1 upon 6 gamma 2, plus there is a link between this now, et and xt. So if you find separately covariance et and xt, you will get this way. Again, in the right hand side, you can put the value, whatever is given, 5 upon 6 xt minus 1 minus 1 upon 6 xt minus 2 plus et, or directly you try to establish this one value. So this is the standard one. If you see this, there is no link between this one and this one. Okay, there is no link between this one and this one, but you will get something from here, covariance et, that is variance of et. And remember here, the assumption et is always this, normal 0 sigma square. These are the IID, okay, and they mean 0, and now presently constant variance sigma square. With this assumption, we are doing everything. Now this will be sigma square. Okay, variance of et, expectation of all the errors are 0, variance sigma square. Okay, so you will get 1 sigma square term extra. Here I will get 1 sigma square term extra. Okay, so then what you need to do is, if you divide by gamma naught, that will come here. Will not do that. So this is equation 3, suppose. Anyway, we don't need this one now. If you are solving for gamma naught, then that will be useful. But in the question, if this one is not given, sigma is not given, you will not be able to do that. In any case, we can solve these two. If you see the question, find rho 0. Okay, rho 0 is always equal to 1. The autocorrelation xt, when you are finding, you will get rho 0. Here rho 1, rho 2. In this case, okay, if I change A to this to AR3, things will change once again. Remember, if I write AR1, the procedure will be the same, but you will get different ways. Okay, so rho naught, rho 1, rho 2. Rho naught is always equal to 1. We'll try to find rho 1 and rho 2 from these two equations. Okay, the first equation will give you rho 1, whatever it is, and then you put the value of rho 1 here, you will get rho 2. You don't need this one now. You don't need this one. In case of AR2, you can find this way, and you need to remember also this way. That will be useful to solve the problems. But most of the time it will be difficult for you to find this way. Suppose I write an equation like this. If I write equation like this, xt is equal to alpha 1 xt minus 1, alpha 2 xt minus 2, then plus et. Okay, this is the AR2. If AR2 is given, remember in this equation, if you try to compare with this equation, here xt minus 1 coefficient is 1, xt minus 2 coefficient is minus r. So I've taken alpha 1, alpha 2. This is 1 and this is minus r. Okay. If you consider this equation, this is AR2. Can you find directly the autocorrelation? That is the question. The question is, can you find the autocorrelations directly? At least the equations. You can solve this, but the equations, can you find directly? That is the question. So Yule-Walker equations will help you. Let's use Yule-Walker equations. Remember, whatever you have done, that will also be useful. Okay, whatever you have done by now, that will also be useful. But you should know Yule-Walker equations. Suppose you have a AR3 or AR4, quickly you will be able to write the equations. It will save a lot of time. So instead of writing all these things, directly you can write the equations. I'll write gamma 3. Okay, see how I'm writing. Here anyway, we don't have gamma 3, gamma 2, gamma 1, then gamma naught. You write all the constants, alpha 1, alpha 2 in every place. If you have a 2 here, you write 1, then you write 0. If you have 1 here, you subtract 1, okay? You will get 0, you subtract 1, you will get minus 1. You subtract 1, this will be minus 1, you subtract 2, it will be minus 2. And when you get gamma naught, you add extra term sigma square. Now considering that, suppose I have written gamma minus 1, that is actually covariance xt plus 1. You can write covariance xt plus 1, xt plus 2, lag 1. Okay, whatever you want, you write x5, x6, x5, x4, whatever you write, it doesn't matter. You will get 1 or minus 1. Gamma 1, gamma minus 1, they are the same. Okay, will not write any minus signs here. So if you replace all minus, we'll make it plus 1, we'll make it plus 2, we'll make it plus 1. Because they are the same. Covariance of AB is equal to covariance of BA. So this is minus 1, we'll write 1 here. This is minus 2, we'll write 2 here. Okay, so these are the equations we derived here. These are the equations. If you see these equations 1, 2, 3. Okay, even if you consider this as your first equation, the numerator, you will get these directly. Once you get these equations, then you divide by gamma naught. Okay, you can use these two to find rho 1 and rho 2. You divide gamma naught throughout this equation and this equation, and then you find rho 1 and rho 2. So you can use Yule-Walker equations. Now suppose I will add one more term. You see the complexity will increase or not? It will not. That is what I want to say. Suppose instead I will write the equation this way. I'll write the equation here. I'll make it AR3. xt, I will write alpha 1 xt minus 1 plus alpha 2 xt minus 2 plus alpha 3 xt minus 3 plus et. So in this case, if you find directly, it will take a lot of time. Okay, if you find directly, it will take a lot of time. But if you use Yule-Walker equations, it will be very easy. It will be very easy for you. So we'll see what we need to change in this case. Okay, we'll see what you need to change here. First of all, we'll start with gamma 3 here, okay? So I have to add one more gamma 3 here, okay? Gamma 3, gamma 2, gamma 1, gamma naught. Here also I'll write alpha 1, alpha 2, and then alpha 3. Plus extra term sigma square. Now you start with 3. You have to write 2 here, 1 here, 0. Start with 2. 1 minus 1 is 1, minus 2 is 2. Then 1, 0, minus 1, minus 2 is 2. 0 minus 1 is 1, minus 2 is 2. Then minus 3 is 3. Okay, sigma square. These are the 4 equations. Using these 4 equations, I mean, the first one you might not be required. When you are finding autocorrelations, you will be able to find row 1, row 2, row 3. You have to solve the equations, that's all. Because alpha 1, alpha 2, alpha 3 will be given. Even if you need to find row 0, that will always be equal to 1. You need to find these from the 3 equations. Now, it's not that you found row 1, row 2, row 3, it's over. You can find using the equations, Yule-Walker equations, or directly. Okay, you can solve and you can find these 3. As we say, AR models are long-term memory models. It will have some dependence to the past. It will not disappear. I mean, the past dependence will not disappear in 2 to 3 or 4 terms. Even if you consider AR1, if I write AR1 here, though we have direct relation with one step, okay, if I write AR1 here, let me consider AR1 process. Now, if I write this, xt is equal to alpha xt minus 1 plus ct. You have row 1, that's fine. Row 0 is 1 anyway. You can find row 1 using Yule-Walker equation. So directly you can find it. So there is a direct relation, that is correlation. You can see t is linked with t minus 1. How about this? If I write this way, xt minus 1 is alpha xt minus 2 plus ct, t minus 1. Then what will happen? You substitute this one here. Then if you see, now alpha square xt minus 2, alpha xt minus 1, alpha et minus 1 plus et. Now see, there is a link between xt minus 2 as well. It's not that you are considering AR1 process, so it will have dependence only up to one level, nothing like that. Okay. So even if you consider AR1 model, there will be a chain of dependency. Suppose you want to find the value here and you think that it will depend through this link. It will depend on this one. Okay. So there is a direct link, this one to this one. This is AR1, right? And this one to this one, direct link. I'm talking about direct link, the autocorrelation. So we'll go to partial autocorrelation also later. There is a link between this one to this one. There is a link between this one to this one. Okay. So this means what? If I make it T, I'm writing the direct relations called autocorrelations. So suppose 10, 9, 8, 7, 6. So recursively, if you see, if you write 10 here, you will have link with 9. If you write 9 here, you will link with 8. So these direct correlations are there. Now, if you change this one, I'm considering AR1, not AR2. AR2 means what? We'll have 2 terms. Okay. I can write this way. In case of AR2, it will be this way. If you write AR2, this will have directly link with this one, this point, and this point. 2. And this point will have link with this one. Let me use a different one. This point will have link with this one, and this point will have link with this one. 2, 2. Okay. AR2. These are the direct link. Okay. But through this one, like if you see this equation, now even if we have considered AR1, even if we have considered AR1, it has link with xt minus 2 as well. Alpha square though, in AR1 process also there is a link. That is why these are long-term memory models. We'll come across MA models towards the end of the class today. We'll see there will be only one step dependency in MA1. We'll see that. But now there is a dependency. So we'll have another question. Let me write that. I'll write the same question. I think it was 5 upon 6 xt minus 1 minus 1 upon 6 xt minus 2 plus CT. Now the question is find the general form of autocorrelation. Find the general form. That means find rho t. That means what? You need to find rho 1, rho 2, rho 3 as well. Okay, rho 4, rho 5, rho 6, all. See here. This is the question. Okay, in this question we found 0, 1, 2. That's all. The same question. Now we want to find all rest also. How can you find? For that, we'll start with the two equations. Okay, we'll start with these two equations. Let me write this one and this one, these two. Rho 1, rho 2 we have already. Then similar to this one, if you find here 3, okay, we found 2 here, then we'll find 3. This looks messy, so let me erase everything. Okay, let me write. This will be my third equation. Okay, rho 3 if you find, if you see the trend here, gamma naught, gamma 1, sorry, rho naught, that is 1, rho 1, you will get rho 2 minus 1 upon 6 here, 0 there. Okay, 2, 1, 0, 1, 0, minus 1, minus 1 is 1, 3, 2, 1 you will get. Okay, that way if you write rho t I can write (5 upon 6) rho t minus 1 minus 1 upon 6 rho t minus 2. So I have not considered here the first one. This one I didn't consider. Okay, so you can write t is greater than or equal to 1. Then you will get this equation. You need to solve this equation. This is a recursion equation. Remember, this is a recursion equation. Okay, or you can say difference equation. To solve these kind of equations, you need formulas. You can solve directly. Okay, so tools are available to solve. You can refer to actuarial table, 3rd or 4th page. Let me write it here. So you remember the equation. We'll solve. Okay, here we'll solve. How to solve this difference equation? Rho t is equal to 5 upon 6 rho t minus 1 minus 1 upon 6 rho t minus 2. Now, if you see actuarial table, we have a formula for this. You have to find b square minus 4ac. You have to bring everyone to the left hand side before solving, and whatever way it's given in terms of t or n, it doesn't matter. Also, you need not worry about t plus 2, n plus 2, n minus 2. Whatever way it is given, okay, I can show you also now. But yeah, will not waste time. You can check it. Although you don't need to use all the time. If first order equation is given, suppose I'll write a simple one. I will write this way, xn is equal to xn minus 1 plus 10. If I write this way, it's very easy. Okay. That means suppose you want to find x10, you write x9 plus 1. If you put 9 here, it will be x8 plus 1. So that way you write x1 here, it's x0 plus 1, sorry, 10. So if you know x0, put here, you get x1, put here, then you get x2, x3, xn, xn. You can find directly. This is first order, okay? Only one term lag is here, so it's easy to solve. You don't need to use any equation. But if I write 2, then that will create a problem, okay? Difference equation, you can compare it with differential equation. We are doing discrete. In continuous, it will be differential equation. But let me write the formula. This is from the actual table. Exactly whatever way it is. So if you want, you can start with n also. Then you will get n minus 1 and here n minus 2. These are the coefficients. So in our case, what are ABC, that you need to determine, okay? And there are three conditions. If e square minus 4ac is positive, then you have a direct solution. Xn is equal to a lambda 1 power n plus b lambda 2 power n. If b square minus 4ac negative, in our case we will achieve this one. Then xn will be equal to a plus bn lambda n, okay? Similarly, if that is 0, we have another. We are not interested now. Because most of the questions you will get, in fact, all the questions till today will normally use this one, okay? We use this one. Even we are doing this question, for more details, you can go through the formula. Now here we'll bring all to the left hand side. Now we write ABC, A is equal to 1, B is equal to minus 5 upon 6, and C is equal to 1 upon 6. And you find B square minus 4 is. B square will be 25 divided by 36 minus 4 divided by 6, okay? 25 divided by 36, this is 4AC. So you multiply by 6, 24 divided by 36, 1 divided by 36 you get. Even if we are not correct, this is positive anyway. I know this should be positive. So directly we can write using the formula the solution for this. The solution for this will be, you write here rho t, okay? That is equal to A is a constant. We have to find A. We'll do that anyway. Lambda 1 power n is here. We can write t. And then B lambda 2 power t. Lambda 2 power t. And here, what are lambda and lambda 2? Lambda 1 and lambda 2. Here, lambda 1 and lambda 2 are the roots. So we already discussed this one. B square minus 4ac is 0. We'll write here a lambda square, not the condition, the whole equation, plus b lambda plus c is equal to 0. Okay. These are the roots, lambda 1 and lambda 2. A lambda square plus b lambda plus c is equal to 0. So you have to solve that equation and find lambda 1 and lambda 2. Let me do that here. So we have some space. What is A? A is 1. Okay. A lambda square plus b lambda. I can do it here. A is 1. Then plus b lambda minus 5 upon 6 lambda. Then plus c is equal to 0. C is 1 upon 6. you solve and find two values of lambda. Okay. So if you solve and find two values of lambda, then you can put here lambda 1 and lambda 2. The only constants you see, a and b, these will remain. Lambda 1, lambda 2, you can substitute from here. Lambda 1 is, I think it's 1 upon 6. And lambda 2 is 1 upon 6. You put here and check. Lambda square, if you put one value, 6 lambda square minus 5 lambda plus 1 is equal to 0. So normally we get 1 upon 2, 2 and 3, 1 upon 2, 1 upon 3 will get, that's all. It doesn't matter. If you interchange also, it doesn't matter. Okay. So finally, we have this. This is the solution. Suppose I will take 1 upon 2 here. Then you need to find the value of a and b as well. To find the values of a and b, we'll use the boundary conditions. Like here the boundary condition was x naught. Here you need boundary conditions. If you check here, already we found the values. We'll use those values. Okay. This is the same question. Okay, I erase, right? You remember the values of row 0 and row 0 anyway we know. Okay. So let me write it here. Row 0 will always be equal to 1. So if I put T0, okay, this will be A multiplied by 1 by 2 plus B multiplied by 1 by 3. So if you put T0, you will get this equation. Row 0 is 1. So we have one equation. A divided by 2 plus B divided by 3. This is one equation. Now take T1. Okay. If you take T1, you will get row 1. This is row 1 actually. If you take T1, this will be row 1. Sorry. This will be row 1. And row 1, we'll see whatever is row 1, we'll put here. This is one equation. If you put T0, here, you'll get A plus B. So 1 is equal to A plus B. Okay, this is equation 2. So you need row 1, that's all. If you see the first equation, okay, we didn't find row 1, I remember. We didn't find row 1. So we'll find row 1 from here. Row 1 from here. Okay. So let's find row 1 from here. You can bring row 1 this side. This will be 1 plus 1 upon 6 row 1. 7 upon 6 row 1 is equal to 5 upon 6 row naught. Row naught is 1 anyway. So I'm not writing anything. You can cancel this also. So row 1 will be equal to 1 upon 5 upon 7. Okay. 5 upon 7. I'll replace it by 5 upon 7. These are the two equations you need to solve. Okay. If this is really correct, 5 upon 7, then you will get the values of A and B. A plus B should be equal to 1. So we have to check whether we will get these or not. Yes, equations, they are correct, but the final equation, just me, I have written somewhere. So when you solve, probably you will get this. I wrote somewhere here only yesterday, but I'm not getting. Okay, when you solve A and B, you will get A 16/7 and B 9/7. Now A plus B is 1, that is satisfied. A plus B, okay. And the other equation also, if you try, it will be satisfied. So let me, I think this is minus, okay, because A plus B will be more. 16 minus 9, that is 7/7 1, okay. So final rho t will be equal to 16/7 t, and then minus 9/7 1/3 power t. That's all. This is the final solution. This is the final one. So let me erase every other thing and we'll write this way. This is the general form of autocorrelation. This is a common question in many of the exams. So you will be able to find easily. Now you can check. You find row 0, row 1, row 2, row 3, row 4. All these you can find. Okay. So if you put 0 here, you can check. If you put 0 here, T0, 16/7 minus 9/7, that is 1. This is satisfied. Then the second one also you can check. You find row 1 here. Okay. Then you have to get 6/7. We found there. Similarly, row 2, row 3, row 4, you can find everything. You can check the first 3, whatever you must have found before using Yule-Walker equations. But now you get all. Okay. You get a lot of rows. And you will be able to know the path dependency. In time series, we want to explore the dependency among the time points, okay, through AR1. That's why these are the long-term ones. We have short-term ones, we'll go to those. These are the MA processes. We are talking about AR processes now, okay. So let's proceed further. This is one type of equation. Even you can use recursion to find this one. You see this question, 1 you write 1. You add 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 5, 3, 8, 8, 5, 13, okay. 13 and 8, that is 21, 34. This is 55 if I'm not wrong. 3, 1, 4, 2, 1, 3, 4, 1, 5, 3, 2, 5, okay. That way it will continue. So if you start writing x0, this one, x1, x2, x3, okay, x4, x5, x6, x7, x8, x9. If you write xt, this will be xt minus 1 plus xt minus 2. This is recursion equation. But what is the solution? Suppose you know this equation. This is Fibonacci equation. Okay. So you know this. Now, if you want to express xt in terms of its previous values, that's fine. If someone will ask what is x5000, you will not be able to answer. You will say it should be x4999 plus 4998. How it can give you some kind of value, because you don't know 4998. So the solution of a difference equation means, okay, already we found in our case time series. That means you will get in terms of t only. Okay, this will be a function of t, so that directly you can find x5000 putting in this equation. This is recursion relation. This is the solution of the recursion equation. Okay, so to find that, we'll apply the same equation. Even suppose you need to find x5000 here this way, it will take a lot of time. Even if you spend a lot of time, you are not sure whether you will be able to find, I mean, whatever you must have found, that is correct or not later. But here, when you get in terms of t, directly you can find x5000, x50,000, 50,000 in 1 or 2 seconds using your calculator. So that is called solution of the difference equation. Okay. We have solution for power 2 that is given in the table. You can take that and you can do it. Now we'll move to MA models. Okay. Now let's move to MA models. If you see this graph here, this is AR. Okay. Let me write here. ARP model. Okay. Now these are the ARP. Even if you take P1, AR1, what will happen? We can say this is linked with this one, direct link. I'm talking about direct one. Okay. These are the values, these are the points, these are the time points, these are the points, and you have to find the value here. These are the past simple, okay? These are the time points where your values. This is not stationary. That's a separate thing. So now if you see here, this depends on this, this depends on this, this depends on this in AR1 and so we consider one step, right? And you need to predict this value. This is our sample. Now what happens is there is a change from here to here. Suppose we have this value, we have this value here, but now where I have this value, there is a change. Now I have from this value to this value, I have a change, okay? So I have a change, it could be through the deterministic model or maybe the stochastic factor. But if the stochastic factor is very high, that means you consider the cells figure, okay? We can consider the fan, suppose the ceiling fan or maybe table fan, whatever you say. Suppose we are talking about the ceiling figure. If you see here, sometimes what happens is it depends on temperature also, okay? Suppose today's temperature is 40 degree. 40 degree fan will not work. This is not Delhi situation, this is Bangalore situation. Suppose here we have 30 degree, okay? Now tomorrow temperature will rise to 32. Day after tomorrow temperature will rise to 34. People buy fans due to their requirement, okay? So there is a long-term requirement, but short-term requirement might increase due to increase in temperature, okay? So you can say the amplified effect, there where the MA term comes. Amplified effect means due to other factors, okay? Though you can take it always the difference, whatever difference is, the amplified difference, okay? Suppose you think that this is contributed due to the random shock, but there might be some other thing, the short-term one. It happens in cricket, you see, okay? So if you can't determine something, okay, unexplained one, that's fine. If something can be explained through some factor, like here the short-term ones, so you can say there is an amplified effect here, okay? If you see the figure, so from here to here, normally we see increase of 5, but we have seen an increase of 12. Suppose it could be due to a short-term one, okay? That you can capture this way. Suppose this is the original one and these are the forecast values. You forecasted here this value, but you got, suppose you started forecasting from here by this time, your original value is this, but you forecasted this, okay? So here also you know the difference, here also you know the difference. These are the errors, you can say. So you know these errors. If you are at t-1 and you want to predict a time t, these errors you know, you don't know this error, okay? So you predicted here at time t-2 that you will get this value, but you got this value. So you know this one, this is the error, okay? Error at time t-1, et-1. This is et-2. This one is et-3. That way you can continue. So if I write MA1 process, okay, let me write MA1 here. MA1 is yt is equal to mu plus beta 1 yt-1. That's all. Sorry, not the previous value, but the previous error. So we'll take a part of error, not y full error. Like I said, the temperature increased 2 degree from last day to yesterday, but from yesterday to today the temperature increased 4 or 5 degree, okay? So exactly whatever error was there will not take the full error, maybe a part of that, 0.2, 0.3, 0.4, 0.5, whatever. So this is the difference between this one. So I'll take here when I predict this one, okay, I'll take the average anyway. Average is mu here, average of the process, okay? Suppose my selling figures are around 10 each day. So tomorrow also when I predict 10 will be there plus, I mean 10, the average is 10 each day. Each day could be 9, 11, 12, 8, whatever, okay? Average I'm saying. Suppose average is 10, that is mu cap. So this one anyway I have to take plus a part of recent error, okay? Recent error I will take. In MA1 I will consider only one error, and This is called one. See, I have not written any y dependent. This is not regression. In regression, auto regression, we take this the value, the past value. We have not taken past value. We have taken the past error. Okay. In that case, the chain of dependence will not be there. We'll see that. And if you write a MA2 process, you will get this way. Y2 will be equal to mu plus beta 1 et minus 1 plus beta 2 et minus 2. That way we'll continue, and we'll have MAQ, like we have taken ARP, MAQ. You need to write YT here. Remember, in each case, beta 1 et minus 1 plus beta 2 et minus 2, and you can go up to beta t, okay, et minus q. We'll go up to beta q et minus q. So this is MAQ process, okay. And if you want to change it, I've written 2 here, q here, that's fine. So what I can do is I can take mu this side, and I can take this as xt. Then xt will be beta 1 et minus 1, beta 2 et minus 2, beta q et minus q, and plus that et part should be there everywhere, okay. This is the stochastic part. This is the deterministic part. Though there is error, but this is past error. This we know already. The stochastic part I have to write, okay. The stochastic part I have to write everywhere. So this is MAQ model. So if I write yt minus q as xt, this mu I have taken here, et will be here, plus all other terms I have already written here, okay.